Hello students, in this session we'll be seeing the most important aspect of geography and the two major theories of geography, that is Continental Drift Theory and Plate Tectonics. When you see at Continental Drift Theory and Plate Tectonics, this is important not just from geography point of view, even to understand the basic structure of the earth, these two theories are important. For you, the questions both in prelims and mains are expected from this particular topic. You should be careful whenever you're reading this particular thing because they may give you a simple and straightforward question. What is Continental Drift Theory talking all about? Or they may give you an example and ask you, how is Rockies mountain formed? Or how is Himalayan mountain formed? Explain it with the help of plate tectonics. So when these kind of questions come, you should be careful in understanding the theory itself. So in this session, what we will be doing is, we'll go through these two theories properly, Continental Drift Theory and Plate Tectonics, and we'll be seeing how did the story come up, what were the evidences that they showed, and what is the evaluation of this. Later, we'll be seeing the application point of it. That is, we'll be seeing earthquakes, volcanoes, and then based on these information, we'll be seeing what is present inside the earth. How these theories help us in understanding what exactly is present inside the earth. So let us begin with Continental Drift Theory. So to begin with, I don't want to get directly into what has actually happened. First, I want you to observe the world map. If you observe world map, most of you right from your childhood is actually seeing these maps, right? What is the peculiarity or what is that you find in the map? Is there anything which interests you? If you see the atlas, you actually observe that these continents which are actually present, they are in such a way that you can fit them together. If you take the case of South American coast and the African coast, you actually see that they both can come together, right? If you see this particular figure, you can see that South America and Africa fit exactly each other. So the same, when you see North America, Europe and all, you can make all these continents together. So is this a new phenomena which you're observing for the first time? Or is the atlas being read by geographers right from the beginning? There was several geographers, meteorologists, whoever used to read about atlas, whoever used to observe it, they found that there is some peculiarity. They used to see that if you see the continents, they're usually in triangular shape. Like, if you take, it is usually in triangular shape. If you take South America, it is in triangular shape. If you take North America, it is in triangular shape. And if you take the case of Pacific Ocean, if you take the case of Atlantic Ocean, you can see that these two form the base and they are present in this form. Here there is another triangle coming up. If you take Indian Ocean, you can see two apices, but two triangles coming in. So what is this? Why is this peculiar arrangement? These were some of the doubts which usually came up. But for GS geography, it is not important for us to see why this particular shapes. But what is important for us is why a particular structure is being present. If you see mountains, they are present in the north-south direction, in North and South Americas. And if you see Eurasia, it is usually present in east-west direction. Why is these differences? This is what was the biggest question in front of most of the geographers. And they wanted to answer it scientifically, not by telling that this has been formed due to God's grace, God has created it. But in 19th century, when you had the rationality behind them and they wanted to observe this. At that point of time, there were several geographers who had discovered several stuff. But what is more important for us from UPSC point of view, or today from Continental Drift Theory point of view, was the views of the famous geographer, that is Alfred Wegener, Alfred Wegener. This person, he was actually observing the atlas carefully. So he found, he was a meteorologist. That is, he was actually studying about the weather phenomena. So when he was observing the weather conditions, climatic conditions across the world, he actually found two main differences. One thing was that whereas glaciers present in the beginning of the introduction chapters, we have seen that glaciers are actually present at higher latitudes, right? That is near poles. You see glaciers, and you see glaciers at higher altitudes in lower latitudes, near equator and all. If you take Himalayas is present in lower latitude, tropical region, but still you see glaciers. But he found glaciers being present across equator. He saw it in Brazil, he saw it in Africa, he saw it in Sri Lanka, he saw it in Australia. He observed why these glacial marks are present in this region. And then he found that there are some coal reserves which are usually present in the polar regions. If you take Canada, if you take Britain, if you take Australia, in the higher latitudes, you actually identify coal. He could not understand these peculiarities. Why coal? Coal, if it is present in tropical regions, you see that coal is formed because of vegetation. That is, let me explain in detail. If you take coal and petrol, right? Just take a scenario where there was floods in a particular area. So what happens? Due to floods, the forest which was there is actually submerged completely. Over a period of time, the river brings its sediments and deposits on these forests or layers, and then after hundreds of years, this turns into coal and petrol. Plants turn into coal and animals usually turn into oil, petrol. If you take higher latitudes, that is Russia, British Isles and all, the coal presence is usually less in these areas, and the reason for this is the vegetation. Plants are usually less. If you take the tropics, the plants were more, and due to this process, you usually find more coal deposits present in the tropics. So this variation had to be seen by Wegener. He was actually confused. How can this variation actually happen? So he thought that there should be two reasons for this. One, if you see, Earth or continents and oceans are not moving, not Earth, continents and oceans are not moving, and there is shifting of climate. Shifting of climate has happened. Sun's rays has moved, equator has changed. This may be one condition. The second condition, what he told was, continents are moving and climate is almost constant. When I say climate is constant, I'm not talking about climate change, but what they mean to say is at equator, you find equatorial rainforest due to high rainfall and high temperature. And at tropics, you see polar, cold, due to sun's rays falling low. You have seen this in the first chapter itself. So he thought either continent should be moving or there should be shift in the sun's rays happening. He thought that as there cannot be shift in sun's rays because scientists or geographers before him has proved that the movement of the sun, rotation, revolution, everything was clear. So he went on and said that this should have been possible only when continents are moving. Till that time, there was a thinking in the geographers that the continents and plates are not moving, they are static. And they were trying to derive theories thinking that these are static. But for the first time, Wegener came out and said that, I think continents are moving. When he said, I think continents are moving, people laughed at him. They told that how is it possible for continents to move? They were confused. But Wegener knows that if he has to prove what he has said is right, he needs evidence. So he started searching for evidence one after the other. He said that initially all the continents were together. He called this to be Pangea or Pangaea. Pan is all or entire. Pangaea is divided into two. Pan, all or entire. Gaea, earth. That is, he said entire earth was together and the remaining portion of the globe was covered with water and it is known as Panthalassa. Pan, again all or entire, and if you see thalassa, it is ocean or water. So he called that Panthalassa and Pangea. So he was actually visualizing the globe where all the continents were together and all ocean was together. He called continents as Pangaea or Pangea and ocean as Panthalassa. And he told over a period of time, they got separated and it has formed what it is today. And when he said this, the first theory or first evidence that he got was the jigsaw fit of the continents. That is, as I told you, the South America and Africa, if you see, they actually fit together. And this, he called it to be evidence one, and it is jigsaw fit of the continents. So was this enough? Is this evidence enough to say that continents were together? At that point of time, he was a bit more confused. He wanted some clarity. He wanted some scientific proof to show that these continents were together. Then, during his time, there was some revolutions happening in biology, in the field of archaeology, where people were actually digging the land and they were actually identifying different species which were present in the earth before human beings came up. And he came across one interesting species, that is Mesosaurus. Mesosaurus, the speciality of Mesosaurus was that it was a reptile and it was a freshwater reptile, and it was present only in shallow water. That is, shallow freshwater reptile. I have divided into three terms: reptile, freshwater, and shallow. The reason is this will help us in understanding why the planets were together. And when he came to know about these freshwater reptiles and he saw where exactly these reptiles are present, he found that they were present in South America in this particular region and they were present in Africa in this region. So if you see the collaboration they actually come together. They were present. If they were connected together, the species could have moved easily from this place to this place. So what he told, these Mesosaurus cannot fly. So they cannot move from South America to Africa or from Africa to South America. Or there should have been some bridges across, or there should have been some stone pillars like Ram Setu through which it should have moved, which is not possible. It should have swum across, which is not possible. The reason being, it is a freshwater reptile. So the possibility, what he told was, if you see the same fossils present on these two sites, then this logic that these two were together is correct. He said that initially when South America and Africa was together, Mesosaurus were actually present. Over a period of time, Mesosaurus got extinct. After that, they were made fossils. After they were made fossils, the separation of the continents took place. This only one species is not enough. So he found several other species like Listosaurus, Glossopteris, and Cynognathus. When he observed all these, he observed that these were present in separate continents, and that could have been possible only when the earth was together. That is when Pangea was there. So he found that you saw the fossil evidence of Listosaurus in these continents. You saw the fossil evidence of Glossopteris, which is actually in this direction. And you saw Mesosaurus in Africa and South America, and Cynognathus also present in South America and Africa. So he said this is possible only when the continents were together. This was his second evidence. That is regarding the fossil remains. This is not enough because he has to prove something more. Then he went back to the library and he was actually observing some meteorological studies on the mountains. So he wanted to prove that the stones which are present in these are also similar. So what he observed interestingly was that the mountains which are present in North America and Europe, they were formed at the same time and they were formed of the same stone. If it was at the same time, he felt maybe it was a coincidence that it was formed at the same time. But if you see, if they are formed of the same rocks, if they are geologically same, then he felt that this should be also a reason. That is, the mountains were formed first and then there was a split. The mountains which he actually found was in North America, Appalachian Mountains. And if you see Africa, Atlas Mountains, you saw mountains in the Greenland, Norway, British Isles, Europe and all. They can come together, club together and form one complete range. If you see Africa, even these two are together. So if you see the pics which are there, the Appalachian Mountains of North America and the Scandinavian mountains or the mountains present here, British Isles and all, they were all formed at the same time. So he told that first the mountains were formed and then there were ruptures and then it started moving. So the third evidence which he showed was similarity, or you can call geological similarity of mountains. This is important. So next, he wanted to prove what he thought in the beginning. That is the presence of glaciers in the equator today and the presence of coal which is present on the outer skirts or on the higher latitudes. The fourth important evidence which he wanted to prove was the glaciers being present. Glaciers. The interesting portion of glaciers itself is that whenever glaciers move on the rocks, like whenever glaciers slide on the rock, glaciers moving, they scratch the stones and they put their movement imprint on that particular rocks. For example, when you go, like, you can see people, whoever have visited, they put their imprints, love symbols and all. Even glaciers put their symbols on these rocks. And these symbols look like these, that is the scratches. And they are known as glacial striations. That is glacial striations, imprint of the glacier movement on the rocks below. So if you take Himalayas today, there is rock and it is completely covered by ice. Whenever the ice moves on the Himalayas, you can see that the movement is being represented on the stone. So that is glacial striations. So he found these glacial striations right from South America till Australia, which is usually present in the equator. And the second thing what he found was the most interesting stuff, that is this rock. This rock is bituminous coal. The interesting fact of this coal is that this is formed only in dense vegetation structures. That is, if you want to form bituminous coal, it should have been formed when the sediments of the evergreen forests were compressed. Then only bituminous coal will form. That is, whenever evergreen, if thick forests are there, and if this forest had undergone continuous sedimentation process, then only you usually see the formation of bituminous coal. So that means wherever bituminous coal is present, there earlier you should have had good deciduous forest or equatorial forest. So wherever bituminous coal is present today, you should have had evergreen forest or deciduous forest before. So he found where all these coal being present. If you see North America, if you see Russia, if you see Australia, if you see South America, Africa, he told that if they are present in the lower ranges, that is, if they are present in the higher latitudes, you usually don't find evergreen forests. So if bituminous coal is present in higher latitudes, it is an indication that evergreen forests were present in these areas where you find bituminous coal today. So this gave an explanation to him. That is, he told that if glaciers are present near equator and if bituminous coal is present in higher latitudes, then there was a period when these lands were rearranged in such a way that wherever bituminous coal is there, equator was passing, and wherever the pole are present, there you actually saw the glaciers being present. So this modification of Wegener was more interesting. So he gave 4 examples or 4 evidences. One is the jigsaw effect, second is regarding the fossils, third mountains, fourth the paleoclimatic, that is past climatic variations. That is, let me just write it, paleoclimatic evidence. These 4 evidences were important.